So we will start now with lesson 4, which is talking about volumes of prism and cylinders. So far, we learned how can we find the surface area of the prism, of the cylinder, of the cone, and of the pyramid. Today now, we will learn how can we find the volume of all of them. Now, what is the volume? The volume is a space that a figure occupies. Like if you have an air, if you have water as an example, you have to fill it in the cube. The amount of this water is a volume. So the volume is the space that is a figure occupies. It's measured in cubic units, not like the area in square units. It's in cubic units, like cubic inches, cubic feet, or cubic centimeters. The volume of the cube is any h raised to the power 3, or any h cubic. So this is for the cube. The first thing that we have to know that if you want to find the volume of the cube, you will say it is the h raised to the power 4. So if you have here this cubic as an example, and you want to find its volume, you will see that this is the edge, and this is the another edge, and this is the third edge. To find its volume, what did we say? The volume of any shape is the area of the base times the height. So this is the volume. If I want to find the volume of any shape, I have to find the area of the base, then I multiply it by the height. The height, which is an altitude that is perpendicular on the plane of the base. So what is the area of the base? Since it is a square, it is this edge squared. A times A, which is A squared, times, what is the height here? It's also E. That's why we said that the volume, of the cubic is E, or the length of the side cubic. This is for the cube. Now, what about the prism and what about the cylinder? Let's talk about the prism. The volume of the prism, it's like as the basic, I mean that the basic formula to find the volume is the base times the height. So it is, if you want to find the volume of the prism, it is the product of the area of the base times the height of the prism. B times H. The volume is B times H. The area of the base times the height, where the height is perpendicular on the base, or the height of the prism. This is now for the volume here. Let's have this example here. In this example here, let's find the volume of a rectangular prism. Now, here we have a prism. It's rectangular. That means its base is rectangle. Now, I have to find. I have to find the volume. Now look at this rectangular prism here. One of you, teacher, I want to make this side. This side here is my base. And I told you that the volume of the prism is the area of the base times height. Now, one of you tell me, teacher, I want to make this is my base, and this is the height that is perpendicular on the base. Let's now, if you consider that this is your base, and this is the height that is perpendicular on the base, what the volume will be? Let's see. Now, look at the base here. It is rectangle. What is the area of the rectangle? Length times width. 24 times what?
10.
Times 10. Is it right?
Yeah.
Isn't it 20?
No, I'm talking about here. Sorry. I'm talking about this rectangle here.
Oh, okay, yeah.
24 times 10. This is for the base. Now, what about the height? Now, this is my base. I will look at an altitude that is perpendicular on the base, which is what?
20.
So now, the volume now is 20 times 10, which is 200 times 24. So the volume
Can't
now.
I say that the height is 10?
No, here. I told you this is your base. This is the height will be. It must be perpendicular on the base. So here now, it is 4,800 centimeter cubic. Now, so I suppose that this is my base and this is an altitude that is perpendicular on the base. Now, as an example, another one, say teacher, no, I want to make, this is how to choose. This rectangle is my base, the down one. Okay, this is my base now. So the volume here is B times H. Now, where's the base? I say it is the rectangle in the bottom. What is its dimensions? 24 times what? 24
multiplied by 10.
By 20. For the base that is down. What is the dimension?
Oh, yeah.
24 times 20. Now, so this is the base that I suppose. Now, where is the altitude that is perpendicular on this base?
10.
It is 10. This one. This one, it is perpendicular on the base. So, times 10. And you will get the same answer. Is it clear?
Yes.
Yes.
Now, for the prism,
Yes.
it's easy. Now, later on, as you see, you will see in the lesson, next lesson for the pyramid, you will say to teacher, which is the base? How can I know which is the base? Is it a triangle? Later on, we will talk about it. So you must know which is the base. For the rectangular prism, you can use any base with its perpendicular height. But later on, you must know which base you are talking about it. Now let's do another example here. What is the volume of the rectangular prism at the right? Here now, the volume, as we said, it is B times H. Where's the base? This is my base. Sorry. This is the base. Now, if I consider now this is my base, what is the area of this base?
15.
It is 5 times
5
3.
times 3.
Now, times. If this is my base, where is the altitude that is perpendicular on the base?
4.
It is 4. So you will say now 15 times 4, which is 60. Now 60 what?
60
What is it? Cubic feet. Thank you.
Because it is prism.
It is a volume. You have the unit of the volume is a cubic.
And teacher, we can say that 4 times 5 is the base and the height is 3, right?
4 times 4.
4.
Where's
4
4
times
times 5?
No,
4 times
5.
5. Yes, and the height is a 3. Yes, if you want to consider that this is your base. Okay. that this is your base, and this is the height that is perpendicular on it. Yes, you can say also. Another one. Say, teacher, I want to make, this is my base, and this is the height that is perpendicular on it. Here, just switch the shape. One of you say that this is my base. One of you say
when you switch
my
it,
base.
yeah.
And one is, you just move, just change the direction of the box, just moving them up and down. You will use any base you want. Now look at this shape here. This one here, as you see, it's a triangular prism. And for this triangular prism, we cannot say that this is this wait, please. This rectangle is my base. Why? Who can tell me why? Why I cannot suppose that? Why I cannot suppose that this rectangle is my base? Why I cannot?
Because we have two bases that are parallel to each other.
Yes.
The triangles.
Yes. That's what I want to tell you. Now here, for this shape, for the prism, I told you that the prism is two polygons, and these two polygons are parallel, to each other, like this one, or like this one. So I told you that the prism, that's mean I have two bases that is perpendicular, parallel to each other. So if I want to find the volume here, and I consider where's the, I want to see which is my base, I look at, if I use this base, is there another base that is parallel to it? Yes, so I will say this is my base. But if you choose this side here, where I have this one, yes, this one here, is there now any parallel face or parallel side that is or any side that's parallel to it? No, so I will not say that's my base. That's why for the rectangular prism, I can choose any base I want, because each two bases will be parallel to each other, only in the rectangular or a rectangular prism. But for the triangular prism, no, you must know where, or for pentagonal, for hexagonal prism, you must know where is my base. So now we say that this is not my base, and my base here is this triangle, because here we have this triangle and we have another parallel triangle, which is the base. So the volume here is B times H. Look at the triangle here. What is the area of the base? What is the area of the triangle?
Half times base times half.
Half times the height times the base. Now don't forget, B small is the length of the base. This is B small, the length of the base. But B capital is the area of the base. So half B times H. Now which H? Here you have two heights. Be careful. Here, there's two. Here, this is H. One of the H's, this is H. And there's also another H, which is this one. That is.
But they're not the height of the triangle. We need to find it, right?
Yeah. So here now we have two heights. If you draw this shape here, where we have to draw it here now. I mean that if you have this triangle, And there's another triangle here. Let's try to connect between them now. What's this? Okay, so now here we note we have, oh sorry, we said that this is my base. And this is my another base. Now, so we have to find the area of the base. Now, I told you here that the area is half b small times h. Now, this b small, it's mean the length of the base, or the length of the side here of the base. The height here, that is a line segment that is perpendicular on the base of the triangle. But after you find the area, this h now is the altitude that is perpendicular on the base. This is my base. Where's the altitude that is perpendicular on it? Which is 10. So this height here is different than the height of the triangle. The height of the triangle, we know it. It is, so let's now come back here to find the area. We say it is half. Now what is the base? This is the base here. Look at here, where's the base? Now here, since we have 8, and this is also it's 8, so the base here is 8. Now, let's find the height. Where's the height? Look at this triangle here. Here we have 8. Here we have 8, and here we have 8. I want to find the height. As we learned before, this is the height. How can we find it? Here we have a right triangle. In this right triangle, this is 8. This is half of 8, which is 4. And we said, we explained before why. And this is now my h. So to find now the height of the triangle, yes, you can use them too. So to find now the height here, you will say 8 squared minus 4 squared equal h squared. 64 minus 16. 64 minus 16 is 50. No, 48, sorry. So 48 is h squared. So the square root of 48, it is 4 square root of 3. So I find now the height. And as I said, the height is the line segment that is perpendicular on the base. So here, the area of the base is 16 square root of 3 inch squared. This is now for what? For the triangle only. Now, let's come back. So this is now the area of the triangle. 16 square root of 3. Now, where's the height? Now this height, that's I want to use, I have to use them to find the volume of the shape is the altitude that is perpendicular on where? On the base. This is my base. Where's the altitude that's perpendicular on the base?
10.
10.
Yes. So now, by now, we found the area, the volume, sorry, 27.12 inch cubic. We found now the volume of this shape. So here now be careful. B small, that's mean the length of the base. B capital, that's mean the area of the base. The height here that I have to use in area. The H here is the line segment that's perpendicular on the base of the in the base, yeah. And H, that is, I have to use it here to find the volume. That is a line segment that is perpendicular between the two bases.
Teacher, but teacher, like the A is not always the H represents the altitude. Like this, we talked before, like the base for the rectangle, it is height times base. The height is the height, right? Not the altitude.
Yes, this is the height here. You mean,
Like,
so you mean that if you want to find the area?
yeah, like
Okay. This is the triangle. If you want to find the area of triangle, you need the length of the base times the height, which is perpendicular on the triangle, on the base of the triangle.
and another H, this one, that with the capital letter B, it is the altitude, not the height, right?
No, I told you for the prism and for the cylinder, they are the same. You mean the slant height and the height?
Yeah.
No, I told you for the
I
prism.
mean this H, yeah, that represents
For the prism and for the cylinder, they are the same. Now, but later on, when we talk about the cone and the pyramid, you have to be careful which height you have to use. Is it clear? So the correct answer here is B. Is it clear?
Yes. Yes.
Okay.
Yeah.
Now,
yeah.
let's talk about a triangular prism, as you see here. This one, it's clear. You have here two right triangles that are, oh, that is my base here. This is the first right triangle and the second right triangle. And since its name is a triangular prism, so, and I told you before that I can name the prism according to the shape of the base. So since it's triangular prism, so the shape here is a triangle. So this is now my base. To find now the volume, I say that is B times H. I need to find the volume, the area of the base times H. Now, look here. What is the area of the triangle? It is half the base times the height. What is the length of the base?
6.
It's 6. And the height that is perpendicular on the base?
10.
Is 10. So the area here is 30 meters squared. This is for the area now of the base. Now, since now I suppose that this is my, or sorry, let's choose this one. This is my base. I need now to look at or to find out the height that is perpendicular on the base. Which is one? Which one?
5.
Just 5. Yes. This is now the height that is perpendicular on the base, which is 5. So the volume here is 150 meter cubic. Is it clear?
Yeah.
Yeah.
No. But please give me 1 minute and I will write back. Let's now talk about or explain how can we find the volume of a cylinder. We talk about how can we find the volume of the prism, now the volume of the cylinder. For the prism and for the volume, we will have the same, or we have the same formula. But here, the base is not changeable. It's not could be triangle, square, rectangle, and pentagon, and so on. It's only every time it will be a circle. So because of that, the volume here since now the volume here is B times H, and we know that the base of the cylinder is a circle, and we know that the area of the base or the area of a circle is pi r squared. So I will say now that the volume is pi r squared times H. This is the volume of the cylinder. If you forget it, remember that the volume is B times H. And you know that the area of a circle is pi r squared, then just evaluate it here, you will find that the volume is pi r squared H. So to find the area, the volume, sorry, of the cylinder, you only need the radius and the height. Let's now do this example here. Where's the cylinder? Okay, 1 minute, please. I forget to take the look at the shape here.
Is it okay so we can see it in our box?
Yeah, please. I want to see the dimensions.
Yeah.
This is now a cylinder. Now, for this cylinder here, he told me that the radius is a 3 centimeter. And the height is 8 centimeter. This is the height here. That is 8 centimeter. Let's find now the volume of the cylinder. We say that the volume is pi, or before that, we say that is B times H. Since now the base here is a circle, so we say pi r squared times H. Pi. Now where's the radius here?
3 squared is 9.
It's 3
squared times where's the height?
8.
It is 8. 9 times 8 is 72. So the volume of the cylinder here is 72 pi with the unit centimeters cubic or cubic centimeters. Is it clear?
Yeah.
Yes.
Yeah.
Now let's talk about now a composite space figure. A composite, like in the two-dimensional shapes, if you see a square or rectangle as an example, and up on this rectangle we have half of the circle like this as an example. And I told you to find this one, we called them composite shape. Why we call them composite shape? Because it's combined, there's two shapes that are combined here. A rectangle. So if you want to find the area now of these two shapes, we say the area of the rectangle plus the area of the triangle. This is now for the two-dimensional shapes. And also for the two-dimensional shapes, we can also add or combine between two figures. So a composite, we call them a composite figure, a space figure, is a three-dimensional figure that is the combination of two or more simpler figures. To find the volume of the composite figure, you have to add the volume of each shape or of each figure, as we did here in the areas. We add the area of the first shape plus the area of the second shape. So as we did, and if you want to find the area of composite shapes, here also we have to do the same to find the area, the volume of the composite figure. But here it's not like the surface area. In the surface area, if you have like half of the cylinder, or I don't talk about sphere, you have a cubic as an example here. Let's imagine here that you have a cubic. And up of the cubic, you have another shape that is pyramid as an example here. Now, for this one here, if you want to find, now be careful, if you want to find the surface area, what did we say? We find the lateral area of the pyramid plus the lateral area, oh my God, so to find the surface area of this shape here, you will find the lateral area of the pyramid plus the lateral area of the cube plus what? The area of the base. Is it right? This is if you have to find the surface area. You add the lateral area of the pyramid plus the lateral area of the cube plus the base. Because you can touch this one and this one and this one. The base, the lateral area of the cube, and the base. This is how can you find the surface area. But if you want to find the volume, okay, you have to add the volume of the pyramid plus the volume of the cube without canceling anything. So the volume here is so easy. You have to add the volume of the pyramid plus the volume of the cube. Sometimes there's a shape, it's like this. You have or I will clean this one. For this one here, so if you want to find the surface area, you have to add the lateral area of the pyramid plus the lateral area of the cube plus the area of the base. And for the volume, you had just add the volume of these three three-dimensional figures, sorry. Sometimes now, if you have this cube and inside this cube, okay, I will draw it quickly because the period will finish. Inside this cube, we have a cylinder. Okay, And I asked, because it's inside it, and I asked you now to find the volume. You will say now the volume is the volume of the cube minus the volume of the cylinder. So if the shape is outside, there are two shapes that are connecting each other. One is up and one is down. They are outside, you add the volume. But the shape, if the figure is inside,